Hi, hello everyone. I am Kusa Raju, currently pursuing my Masters in Signal Processing and Communication at IIT Tirupati. Today I am here to give a presentation on the paper titled Joint Deployment and Pricing of Next Generation Wi-Fi Networks as a part of Communication Networks course. This paper got published in IEEE Transactions on Communications in 2019. Hardly it's been a year. These are the authors of the paper. Now let's get into the details. Let's look at the problem that the paper is addressing. We can view it as a problem in solution of a problem. It would be understood as we go on. The mobile data users are continuously increasing. In the current scenario also, a lot of data is required for learning, distance working, as in the current scenario also. Even it is not the issue, globally the mobile data users are increasing a lot, threatening to drain the cellular network capacity, causing more complaints from the users. Because as the more users are increasing, their data speeds are falling. So more complaints from the users. So how to tackle this thing? The cellular networks are looking at the solutions. The solution to increase cellular capacity is to use Wi-Fi. That is offloading the data traffic that is there on cellular networks. That is shifting the data traffic from cellular networks to Wi-Fi. The factors that favoring the carriers is the Wi-Fi spectrum is unlicensed and the data rates are pretty higher over the Wi-Fi. And the mobile technology and the Wi-Fi technologies are converging day by day. And it is expected it would be even more in the next generation networks. So, but the problem in this solution is where to deploy the Wi-Fi access points and how the pricing should be. In the current scenario, currently it is being done in an ad hoc manner, heuristically where the dense areas are there and where the installation charges will be lower. Considering these things, the carriers are deploying the Wi-Fi IAPs. But how to make it better, more generalized, so that the carriers will get profits? This problem is addressed in this paper. What needs to be done is we have to study the deployment policy that maximizes the carrier profit and how the pricing affects the user demand between Wi-Fi and cellular. What that means, what are the preferences of users? But the users are often unpredictable. So to cover wide spectrum of users, we have to analyze more different types of models. These are the different models to capture user demand. That is maximum surplus demand, constant elasticity demand, logit demand. In all these demands for each of the demand models, a JWDP, a joint Wi-Fi AP deployment and pricing problem will be formulated, and with the intention of maximizing the carrier's profit. Before going into these models, let's look at the carrier model. A virtual carrier is considered. The difference between virtual carrier and carrier is in an agreement to the cellular networks, the virtual carrier, the policymakers will buy the telecom services in a bulk amounts from the cellular networks, and then they will come up with their own plans to that geographical area. Example, Google, Republic Wireless, and so on are the virtual carriers. They don't have cellular infrastructure, so they will send their user data through the cellular networks. For example, Sprint and T-Mobile, like that. For that, the virtual carriers have to pay to cellular networks. For the viability of the virtual carrier, they will charge from the users. Here it is shown that PACA, PBCB. P stands for payments, C for costs. PACA related to access points, PBCB related to base stations. So what are the costs that are incurred in the Wi-Fi deployments? Let's see. And this virtual carrier and carrier, we can view it as a wholesale and retail like analogy. And in India, considering in India, Airwas is the first virtual network operator in India. Let's get into the costs that incur in the deployments of AP. Different costs associated with the Wi-Fi deployment is operational costs and capital investment. To install this Wi-Fi APs, the carriers have to acquire some space, some land. They have to rental, and then that Wi-Fi equipment installation and the labor supply and so many things. And the capital investment is once in a while, but this operational costs and maintenance on a monthly basis or some period of study altogether contributes to the deployment cost D in a site N. The user will be requested to pay price PA, which is a pricing policy, introducing the variable X that denotes whether the AP is deployed in a site or not. This states the deployments policy of the carrier. Now let's get into the user demand models. First one is the maximum surplus demand, and the name indicating maximum surplus. For suppose taking the market, the seller provides different products. The product which gives maximum surplus, that one is chosen by the user or subscribers, like in our data market, data networks. The surplus is the difference between the seller decided price and the price that the user willing to pay the max. LKA is the kth subscriber or kth user willing price for the access point. So the surplus will be difference between the user billing price and the price decided by the carrier. For cellular as well, the demand for AP is the all the set of users that will connect to Wi-Fi access point. The demand for cellular is the all the set of users that will connect to base station. Cellular, they will take the data services through cellular instead Wi-Fi. The limitation of this model is we have to have the user preferences, user behavior. So for that, if the area is small enough, if the populated is small, then the carriers will take this info from conducting some service like that. But for the large populated, large geographical areas, it is it's not a good model. For that, we have some other models. Let's get into the next model. This is constant elasticity demand model. It doesn't require the behavior of users as in MSD model. The demand for access point is given by Bn by Pa to the power of R, where R is the price sensitivity, Pa is the price that is set by the carrier, and Vn is the valuation coefficient to that particular site. And the demand for base station at the cellular network is total cellular network demand minus the traffic that is uploaded to Wi-Fi. That remaining will be to base station. How this demand is varies with the price is shown here. As the price is increasing, the demand is decreasing. The demand of AP is decreasing. It is taper to the price sensitivity. Users will respond over to the price sensitivity. This can be applied to large populated area also, because we don't need to get the information from the user. Here the demands are independent to the another access point. This is the logit demand model. In this, the demand is determined probabilistically using surplus values. The probability that the user chooses the Wi-Fi or base station given here in probabilistic manner. And the demand for access point and base station are the corresponding probabilities multiplied by total cellular demand. As you can see here in the graph, as the valuation coefficient for the access point 2 is increasing, as it is increasing, its demand is increasing, the red dotted lines, and the access point 1 is decreasing. You can understand it as suppose a particular venue is more popular, automatically it attracts more users, like that. For any of the demand model, a joint Wi-Fi deployment and pricing policy problem will be formulated. The carrier profit is the difference between payments and costs. This is for Wi-Fi access point. This is for base station. So we have to find the pricing policy and the deployment, maximizing the carrier profit. It is an optimization problem. These are the results shown. How as the price is increasing, how the user demand changes. User demand is changing. So correspondingly profit changing. So with the price, how user demands are changing in the CED model and LD model shown here. And compared to ad hoc manner, how this our procedural generalized method gives the profit. Here it is shown. The the red line shows the ad hoc manner Wi-Fi API deployment, and it is of our procedures. It is giving more difference, more profit than in ad hoc manner. These are the few references that are mentioned in the paper. And Google project file, that the virtual carrier in the US, it switches between the three cellular networks. The signal, based on signal strength and speed, automatically switches between among the all three or four cellular networks, and it automatically comes to Wi-Fi as well. Thank you.